This is E3, Basic Engineering Costs and Benefits. Chan, Chapter 8, spread out a little through Chan actually, this material. Noonan et al., Chapter 2, Summary Notes, E3, any principles text. You don't need to check on a principles text, but if you look in Krugman Chapter 11, you'll find a detailed exposition about costs that would be suitable for a principles level class, which is what we're doing here. So costs are divided into two main types. So the most important distinction for economists is whether a cost is fixed or variable. And a fixed cost is invariant with respect to output. A good example of that might be you have a loan, a 5-year auto loan on a truck that is part of your business, your landscaping business. And so even if you never cut any lawns or go on any business calls, you're still going to have to pay for the loan on the truck. So that's a fixed cost. Obviously, in the long run, you can avoid fixed costs. Long run in economics is actually defined in a circular way as a time period sufficiently long that you can get out of your fixed costs. So in the long run, you avoid fixed costs. You could sell a fixed factor. You could sell the truck. But in the short run, we see costs as potentially being fixed, or else they could be variable. And a variable cost is one that will vary with the level of output. So an example of that might be that you have labor working for you, and so you have to pay more wages if you produce more output, or you have more raw materials that you have to buy. And total cost is the sum of fixed and variable cost. Let's abbreviate that as TC, and we'll call this fixed cost and variable cost. We could call it total fixed, total variable, I guess. But so fixed cost plus variable cost. So if we add up all our fixed and variable costs, we get total cost. A few interesting concepts that we can consider is average total cost is the total cost divided by the output produced. So Q, as I've said before, stands for output or quantity produced. So that tells us cost per unit. Another thing that's interesting, sorry, my cat just stepped on something. Okay, average fixed cost is the fixed cost divided by output. And you'll notice that if a cost is fixed, then the higher the output, then obviously average fixed cost is falling. And so this is something that you're probably familiar with, the idea that you can spread fixed costs over larger levels of output. So that's one of the reasons why you might want to boost production, because you can cover all your fixed costs. So that's the average total cost. Another interesting concept is marginal cost, which is used a lot in economics and engineering economics. And marginal cost is the change in total cost with respect to a change in output. And so the marginal cost does not have to have any particular relationship to average total cost. It will depend. Sometimes marginal cost is bigger than average total cost, which means that the additional unit of output is more expensive for some reason, or it could be less. And we go into more detail in that in the notes. So that's the marginal cost. Let me give you a very simple cost example using what's called the break-even point. And we go back to the break-even point later in the class and talk about it using examples where the costs and benefits accrue through time, so we have to take account of the time value of money. But let's do a very simple break-even example where we're not going to worry about the time value of money. Let's say this is all happening very fast, but we have a situation where maybe we want to open a little taco stand at Portland Saturday Market, which meets at Portland State on Saturdays, and let's say the market is going to charge us $100 a day to have a stand. They'll set up the table. We just have to bring our ingredients, and that we want to figure out whether it be worth setting up this taco stand. And so then we need to calculate what's called the break-even point. And break-even point is the point where the total revenue is exactly equal to total cost. Okay, so we've got all our costs here as we've described them, and then total revenue, TR stands for total revenue, is price times quantity. All right, and let's make up some more information about our taco stand. Let's say they're very fancy tacos and that we think we can sell them for $10 each. We've done some market research and they're full of lobster or something. They're very nice and we could maybe sell them for $10 each. And that the ingredients involved in every taco is going to cost us about $5. Maybe that includes a measure of our labor cost if we have decided that our time is worth a certain amount. Maybe on a Saturday we don't think our time is worth much. It's not competing, our time is always worth something. But let's say that this is the additional cost of supplying tacos. So we're going to measure the revenue and the cost on the vertical axis and the number of tacos on the horizontal axis. So we start thinking about revenue. The revenue, to find the revenue, we'll have to multiply $10 by Q. So for example, if we have no Q, no output, revenue will be 0. So that's a point on the total revenue curve. And then if we make 10 tacos, $10 times 10 is 100. So 1 point on the total revenue curve is that if we make 10 tacos, we can have $100. And then if we make, say, 20 tacos, we'll just do a few points. 20 times $10 for the price, the revenue will double and be $200. So we draw our total revenue curve just by multiplying price by quantity. And then for total cost, we have a fixed cost of $100. So our total cost curve starts here. Even if we make no tacos, we still have to pay $100 to the Saturday market. And then every time we make tacos, the cost goes up by $5. So for example, the total cost of making 10 tacos is going to be $100 plus 5 times 10. So that's 150. So let's get that point in here. So we've got 2 points on our total cost curve. Now we have when taco production is 0, total cost is 100. It's just the fixed cost. When taco production is 10, total cost will be $150. So that would be 100 plus the variable cost associated with producing 10 tacos. And then let's think about what it would cost to make 20 tacos. Again, we've got $100 in fixed cost. $5 times 20 is going to be another $100 for the variable cost. So the total cost of making 20 tacos is $200. And so this, we could keep going, and if we do, you can see that because the slope of the total cost curve is below the slope, is lower than the slope of the total revenue curve, you can see that they cross. So as we go further out in terms of making tacos, you can see that the gap between total revenue and total cost is getting bigger, which means now we're in a situation where we're making increasing profits. But this thing here, this is the break-even point. So often when businesses are starting out, as a very crude measure of whether they should even go into an activity, they will calculate a break-even point. So given all the costs that we have and our projected revenue, how much would we have to make to at least cover our costs? And as I say, we return to this idea of a break-even point later in the class using time value of money calculations, economic equivalence calculations. All right, so this is Basic Engineering Costs and Benefits, and I'll see you in the next video.